Hello, so I am back with another video on the calculator, and this one we are going to be making the adder for the calculator. So the part that adds. This may, I just want to say, look a little bit different from last time. I just finished failing at making a video, so I'm going to try, I was trying to do something to this that ended up not working, so we're going to do it in a different way that hopefully should work. So essentially, right now, all these are in the order A, B, 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 B. If that makes sense. We need them to be an A, B, A, B, A, B, A, B. So instead of going 1A, 2A, 3A, 4A, 1B, 2B, it's not 3A, 4A, it's 4A, 8B, 8A, sorry. But you get the idea. Instead of being like that, you need it to be like 1A, 1B, 2A, 2B, 4A, 4B, and so on. So we need to add repeaters here because these are only going to give a signal strength long enough to reach 1 redstone dust normally. Put that in there. It hits. You can see that it immediately runs out. It's only powering here. So that's why we need the repeaters. Okay, and so now we need to rearrange the outputs. So I'm not sure how much space we're going to need. I'm just going to create one of 15 length. And I'm also going to put in the number 15 for, that's a problem. That's the explanation behind the problem. I put number 15 in for both of them so that we can see them on and see where we need to add repeaters and things. So all those are on, which is good. Redstone is disappearing. Still need to get code crafted because I keep forgetting to do that. So I'm just going to set them to be this far. It's probably not going to need to be this far, but anyway, so that's 1A. Now let's bring in 2A. And I'm not going to add repeaters yet because we're going to end up changing it later. It's not going to end up needing to go this far, so. And the well, we can fix it, maybe. Let's see. Now we need to get 2A in, so if I place the block here, you can tell by the signal strength that this is powering this. So there still is a strength there, so maybe, nah, never mind. Just bring this back. All of the animals in my house are being pretty loud right now, so you may be able to hear them. Just to let you know. So this one is going to come over to here. Okay, and now we need 2B. So this one is going to, once again, be pretty simple. Just do this. And you don't I should mention this before, you don't have to do this the way I'm doing it. This is just one possible way to rearrange the outputs. You can do it in whichever way works for you, just as long as they're arranged in the same way mine are. Okay, so now we need to get this one over to this line here. Sometimes it helps to go backwards. There we go, except I missed 2. Then we need, so that was 3A. Yes, so now we need 3B. The B ones tends to be fairly simple compared to the A ones. Okay, yeah, all of the B's, it's just curving a signal and bringing it in. 4B is going to be really easy. 4A is going to be really difficult. Let's see how we can do this. Well, this looks like it will work. And there we go. Now we just need 4B, the last input, and so this is how we're going to arrange them, unless you did it differently, which, as I said, is perfectly fine. But I am going to change this a little bit just to shrink it slightly. Move that there, which means that this can go down quicker. Also, oh, there we go. So we can put repeaters at the end of all of these. It looks like they're all going to reach. You don't have to have a repeater, really, because, well, you might for some of them, but I just like them to all have repeaters. It's nice. It's only 1/10 of a second more, I mean, so, yeah. Break all of this, and now we have our outputs, but we still need to do more. So we need to take these outputs and put them into an XOR gate. Well, a bunch of XOR gates, really. This is how you do addition in binary using an XOR gate. So essentially, let me get a lever. Essentially, the way an XOR gate works is, well, let me build one and I'll explain how it works. And what it does, it's not called an XOR gate because it looks like an X. I'll say that you spell that XOR, like that. It's not just the letter X and then OR, not like EXOAR or anything weird. Oops. So essentially, the way this works is, if you know what an OR gate is, really a very simple example of an OR gate is, well, this, really, where if one or both outputs are on, then it will give an output. So you have the 2 inputs here and here, an output. I think the official way to make an OR gate is something like, well, I don't know if it is official, I've seen it like this before, like that, but it's really the same thing. So an XOR gate, it's short for exclusive OR gate, which means that, well, what it does is it will give an output if and only if one of the outputs is on. So an OR gate will give an output if one or both is on. This one will only give an output if one is on. So if you can see, there's no output when none of them are on, but if I turn this one on, there's an output. If I turn this on, there's an output. If I turn both of them on, there's no output because it triggers the AND gate, which turns it off. And you can do addition using a modified version of that, also subtraction, and it'll be used for multiplication and division as well. XOR gates are the building block for all binary calculations, I guess. So essentially what we're going to need to do, though, is we need to actually bring these over. How did the repeater and the redstone switch places? How did that happen? Okay, that was weird. Anyways, we need to build them up like this, and that's gonna come in later. You'll see. Going to change this a little bit more. It will make it slightly easier in that other part. Yeah. Okay. And we'll need redstone on there later, but right now it's not really necessary, so I'll just leave it blank. So we have these. I'll leave it on. Why not? So essentially what we need to do I say essentially a lot? Maybe I do. Well, we need to build an XOR gate. But this needs to be, well, let me think for a moment. Okay. This first one is going to be a little bit different. So we'll all, okay. We need to make an XOR gate, but we need to do this on the top. And so normally you'd have it, or torch here. Now let me just start over again, because I went a little bit fast there. Make sure you can see it. So the redstone will run to blocks, which will get inverted, run into another redstone signal, and then both of them will get inverted again and be combined into the same signal. Then both of these torches will power the same redstone dust, which will power a torch here. And this is a normal XOR gate. But the one we need, it needs to have a carryout for addition. So we need to actually place a block there with 3 torches on it like this. And each of these torches will power these. So it does essentially the same thing. Just have this torch we could use and take an output from it here. You'll see later. But if you did everything right, there shouldn't be an output. And that's the first one. The other ones are going to be a little bit more complicated. So, number 2, for the 2s, this was the 1s. For the 2s, it's the same XOR gates design at first. Like this. And then though, we need to put that into another one, just a normal XOR gate. Oops. Did not mean to open up my inventory. There we go. So this is the second XOR gate. And now we need to do something with this in it. So if there's two ones, then this torch will turn on, and, well, two ones, you can do the math. 1 plus 1 is 2. So we need to bring that into the 2 section. So that's what this second input for. The first one is just for the normal numbers, and then the other one is for the carryout. So it's gonna need to come into here. Need to block the signal there, which will also work out because it's gonna be a carryout here, and it's called a carryout or a carryover. I don't know, and I don't care. Anyways, we just need to bring that there, and then we can, now that we know how long this is going to be, you can bring this other input here. So there's going to be no ones, 1, 2, and this is for 15 plus 15, which is 1, 1, 1, 1, plus 1, 1, 1, 1, which will end up being 1, 1, 1, 1, 0. So you'll see that soon. There's not redstone there. That could cause problems later. Okay. So now, let's make the next one. And then building it wrong. Just the same as the second one. And run that into the input of another XOR gate. This should not be giving output. That is why. Okay, so we need to run the carryout from the second one into there, but we don't want the signal to overlap here, so we need to place a block there. Hopefully this is making sense. You might have just heard a really loud noise. The microphone on my earbuds hit the table. But now I just need one more for the 8s. Wait, did I finish this one? Forgot to put that there. That can cause problems. And took me a while to place that one piece of redstone. And there we go. So this is the final XOR gate. Now I just need to take the signal from this torch and bring it in here like so. Like so. Now, you may notice a problem. This is not 11110. This is 1110. That's because with addition, you will always end up with a maximum of 1 of extra number from what you put in. Since we're doing 4 bits plus 4 bits, it could end up being 5 bits. 5th number. 1, 2, 3, 4, 5. So we are going to solve that by adding another thing here, and so this here is 16s, this output here, if that's on. And since it's on, this will turn on if there's a 16 output, and that is why we are not getting the right number. But since there's no other 16s, we can just bring it straight out here. And now, this is the addition segment of our calculator, believe it or not, complete by random item.